Today we're going to talk about how measurements are expressed. And there's two ways of expressing measurements. One way to express a measurement is using ordinary decimal type numbers. And the other way of expressing a measurement is using scientific notation. And depending on what type of a number and what type of situation that you're going to be dealing with numbers, you express them in different ways. So an example of an ordinary type of decimal number would be something like 0.1973. And so that's something we've seen before. But this number can be expressed in a different way using scientific notation, and that would be in the form of 1.973 times 10 to the negative first. So what's the relationship that exists between these two? How do we go from one way of expressing a measurement to another? And to do that, we have to follow a general format when we write scientific notation. And that general format would be having a number with a decimal point after it, and if there are any other numbers after it, whatever number that might be, times 10 to the power. And let's talk about this power and what this means. Now, when the power that you have is a positive value, this represents a large number, or a larger number than 1. When you have a negative power, this represents a number that's smaller than 1. Now, let's take a look at some numbers and how we go back and forth from one to the other. For example, if you have a number, a decimal, ordinary decimal number, 0.000551, to express that in scientific notation, what you would do is that you would take the number and locate the decimal point and move the decimal point the number of times to get that decimal point from where it is to just to the right of the first non-zero digit that you have. And when you do that, you end up with 5.51 times 10 to the, now here we go with the power. How many times did we move it? 1, 2, 3, 4 times. Now this number is smaller than 1. So in this case we're going to have a negative exponent. Now if we had a positive exponent, that number would be larger than 1. And is this, you have to evaluate this number and say, is this number larger than 1? And the answer is no. In the other direction, say we have a number that is very large. For example, 7241. And if we want to express that in scientific notation, you have to first identify again where the decimal is. And so, again, it's right here. So how many places do we have to move it? 1, 2, 3 places. Again, 7.241 times 10 to the, we moved it 3 places, so put a 3. Is our number larger than 1? And the answer would be yes. So that would be a positive exponent. And so we could leave it here as just a 3, or if we want we could put a positive, but generally we just leave it as a 3. Now going in the opposite direction, if we have a number in scientific notation and we wanted to express it outright as a decimal, for example 9.951 times 10 to the third power, and we want to express that. Again, we have our number with our decimal point right after the first non-zero, and we're going to move it 3 places. Now, since this number is larger, is a positive number, it's larger than 1, so we're going to be moving it to the right. So that would be 9951, and so we move it how many spaces? It was here, we're going to move it 1, 2, 3. And so our number then becomes 9951. If we have a number that has a small exponent, for example, 7.9 0.83 times 10 to the negative second. Here in this case, again, we're going to be moving it that number of times, and since it's a negative number, it's going to be smaller than 1. So 783, and since it's a smaller number, smaller than 1, we're going to be moving it 2 times. So we're going to move it 1, 2. So our decimal point moves 1, 2 times, and our number then now becomes 0.0783. And this is how we express numbers, ordinary decimal numbers, into scientific notation, and scientific notation back into ordinary numbers.